The ALU of the F18A computer is continually examining its inputs from the S&T registers and continually developing all of its possible results. Generally speaking, ALU operators therefore need only to select the appropriate output from the ALU rather than waiting for an ALU operation to finish. The exception to this rule is addition. Whenever you use the plus opcode, you must consider whether there has been enough time elapsed between the last change to S or T and the use of the plus opcode. If the last change made to S or T was in a slot of the same instruction word as is depicted here, for example by use of a literal and a plus, if that's all happening within a single instruction word, you must put a no-op in there. Likewise, if this is any other instruction such as pop, push, over, dupe, drop, 2*, 2/, minus, any of those things which change S or T, you should code a no-op in between the two phenomena. If there is an instruction fetch involved, or a jump or a call, or a micronext loop, you can arrange to achieve the time delay without having to use a no-op. For example, if the last slot of the preceding instruction, if it does it with a memory operation such as a literal, this would be a fetch p opcode here, there's absolutely positively enough time for the ALU to stabilize before a plus occurs in the first slot of the next instruction word. Micronext induces enough of a time delay to allow the ALU to stabilize, so addition in a micronext loop should work fine. Addition is not a problem if it is the first thing done by a subroutine that you call. So a call to Joe introduces enough of a time delay that there is definitely no problem. And likewise, a return from Bob takes long enough that a plus may be used safely immediately after that. If you're in doubt, insert a no-op. But if you're careful in planning the way your code is laid out in consecutive instruction words, you can often avoid the use of a slot for the no-op.